Let's do case A, which is changing the temperature of the heater from 40 Celsius down to 30 Celsius. So let's go, and this is our main simulation, our chemical process. So this is, let's say, that the original case, and let's go to the second simulation, case A. So this one is the same, case A. What I'm going to do here is essentially change the temperature of the heater to from 40 Celsius to 30. So click next, run, okay. Hopefully there are no errors and no warnings. So the problem, if there isn't any kind of error, it's probably because there is a change in distribution of mass transfer, and this column is based on our previous material, so that might be a case. But we have everything fine, so let's check out. And I want to compare the product lines, so here I selected my products, which is stack, LPG, prod C6 and C7. And here it goes. Let me go here so we can compare directly. This is the original case. Let me verify. The rich material here is benzene and toluene, so let's base our analysis here. So we got 30 and 20, and here we got 31 and 20. So technically it's almost the same. The main problem, let's see about the purity. So for our toluene stream, we want to maximize toluene. So if we increase the 95%, that will be great. And the main problem is, no, we are not achieving that. Actually, just because we decrease 10 Celsius on the heater, the main effect on our process is that we dropped down to 91%. So definitely, if you want to improve the purity of toluene in this stream, this is not recommended. Actually, I will encourage you to change for a higher temperature and verify what will be the results. Talking about the purity of the C6, we have traces, and right now we have a little bit much more of butane. 4% might be not the best case scenario on a C6 product. Actually, it's a very high amount of butane, I will say. So no, you should not proceed with this temperature change.